True Projects. In this video, we are going to explain about the project, which is data imputation for multivariate time series sensor data with large gaps of missing data. In many fields like environmental monitoring, structural health analysis, bioinformatics, and IoT applications, data collected by sensors frequently contain gaps or missing information. Data imputation is a crucial process of filling in these gaps with estimated values. It is essential because it prepares the data for further analysis, ensuring that data-driven models or physics-based simulations have complete and usable datasets to work with. This project tackles a significant problem related to missing data. By improving handling these gaps, it has the potential to boost the reliability and quality of insights and decisions made using the data across various domains. The project introduces an innovative method to enhance the multivariate imputation by chain equations, which is MICE technique. It achieves this by transforming the original sensor data in a way that allows it to better leveraging the connections between missing data and observed data, ultimately resulting in more accurate imputations. The main goal of the project is to improve the accuracy of data imputation for missing sensor collected data. The project utilizes a combination of machine learning algorithms, including decision trees, k-nearest neighbor, which is KNN, support vector machine, which is SVM, multi-layer perceptron, which is MLP, gradient boosting, linear regression, random forest, and voting regression for data imputation. These algorithms play a crucial role in reshaping and imputing the sensor data effectively. They help in leveraging correlations between missing and observed data, especially in scenarios where irregularly spaced peaks, ultimately enhancing imputation accuracy. The ultimate goal of the project is to provide accurate and complete sensor data for downstream analysis and modeling. By achieving this, it aims to enable better informed decision making and more reliable data-driven insights across various domains, ranging from environmental monitoring to IoT applications, which are Internet of Things applications. For implementing this project, we need hardware and software requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above are needed. In software requirements, we need Anaconda 3 and Visual Studio Community version. To implement this project, we have designed few modules in the flow of work. The first one is importing the packages. This module involves importing the necessary software libraries and tools required for project's execution. The first one is NumPy. It is used for numerical operations, and Pandas is imported for data manipulation, TensorFlow for a deep learning framework, Matplotlib and Seaborn for visualization, Scikit-learn for machine learning, transformers are used for natural language processing. Exploring the dataset. This step involves data inspection and exploration to understand its structure, contents, and the characteristics. Data processing. This module handles data processing tasks like cleaning, formatting, and organizing the data for analysis. Defining the outliers. This step involves identifying and defining the outliers in the data, which are the data points that deviate significantly from the norm. Data transformation. This module focuses on transforming the data, ensuring it aligns with the assumptions of machine learning models. Reshaping the data. In this step, the original sensor data is reshaped to leverage correlations between missing and observed data, enhancing imputation accuracy. Splitting data into train and test. This module involves dividing the dataset into training and testing subsets, which are crucial steps for model evaluation. Building the model. This section involves developing various machine learning models for data imputation, all with the focus on MIC. The first one is decision tree. Decision trees are used in this project to impute missing data by creating a tree-like model of decisions based on observed data, aiding accurate imputation. K-nearest neighbor, which is KNN. It is employed for imputation as it finds the k-nearest neighbor of missing data points, imputing values based on their neighbors' information, enhancing imputation accuracy. SVM, which is support vector machine. It assists in imputing data by identifying the hyperplane that best separates missing from observed data, aiding accurate imputation. MLP, which is multi-layer perceptron. It is used to capture complex relationships between missing and observed data. contributing to improved imputation accuracy. Gradient boosting. It is applied to iteratively build strong predictive model, reducing imputation error and enhancing data quality. Linear. Linear regression is used for imputation by modeling the linear relationship between missing and observed data. Random forest. Random forest is employed to create ensemble of decision trees, leading to more robust and accurate data imputation. Voting regression. Voting regression combines multiple regression models, improving imputation accuracy by considering diverse perspectives. Function sequencing the data. This step involves organizing functions to process and sequence the data through various stages of the project. Selecting the feature. Here, feature selection techniques are applied to choose the most relevant variable for modeling. Function of validating the data. This module comprises the functions for validating and assessing the quality and accuracy of the data at different stages. Building the model. In this section, specialized models like MLSTM, MRNN and GAIN are constructed. MLSTM, which is multi-layer LSTM. It is used to capture long-term dependencies in the data, enhancing imputation accuracy in time series scenarios. MRNN, which is multi-layer RNN. It helps model sequential patterns in the data, contributing to accurate imputation, especially in time series data. GAIN, which is Generative Adversarial Imputation Network. It leverages generative adversarial networks to impute missing data, enhancing the accuracy by generating realistic data values. Training the model. This step involves training the machine learning and deep learning models on the prepared data. Flask framework with SQLite for sign up and sign in. This module sets up a web framework using Flask with SQLite database for user registration and authentication. User gives input. User provides input or data for model's predictions. The given input is pre-processed for the prediction. The user input undergoes pre-processing to make it suitable for input to the trained model. Trained model is used for prediction. The trained machine learning or deep learning model processes the pre-processed input to make predictions or generate outcomes. Final outcome is displayed through frontend. The results or predictions from the model are presented to the user through the project's front-end interface. For execution of the project, we need to open the code folder which contains the source code files. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign-up file. This file is the database file used to store the user information. This is the model file which contains the algorithm information, and this will be loaded into the project code during runtime. Now we need to copy the path of the code folder from the address bar of the file explorer. So now we'll copy this and open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path. This command is used to change the current directory to the code folder's path. Now we will click on enter. So the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile the app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost and the port number, unless configured differently. This is the localhost and this is the port number. Now we need to copy this local link provided by the Flask framework and paste it in any browser. So we will copy this and paste it in the browser, which is Google Chrome. So here we will paste it and then click on enter. This homepage of the project is displayed in the web browser, and this is built by using the Flask framework. Now we will click on sign up. We need to enter registration details if we are registering newly. I have already registered, so I'll directly click on sign in. Now I'll enter my credentials, which are my username and the password, and click on login so that I'll be logged in. So it has redirected to the homepage of the project where we need to fill all these parameters and then click on predict. By that we will get the rainfall prediction after imputation. Now we will fill all these details step by step. So here we will enter the Harley relative humidity, which is 66, and the Harley sea level pressure is 29.96, and the Harley station pressure is 28.6, and Harley visibility is 10, and Harley wet bulb temperature is 29, and the wind speed is 7, and the Ozark aquifer depth to water level is 220.24, and the weekday is 1, and the day or night as 2. Now we will click on predict. This web interface will give the output after imputing the missing values and the gap data. So it is predicted that the heavy rain between 10 mm and 50 mm per hour. Now we will give other parameters and then see what will be predicted. So here we will enter 78 as, and this will be 29.97, and the station pressure is 28.6, and the visibility is 10, and the wet bulb temperature is 26, and the wind speed is 3, and this one has 220.23, and the weekday as 2, and the day or night as 1, which means it is day. Now we will click on predict. So based on the input, it is predicted that the rain is moderate, and when the precipitation rate is between 2.5 mm and 7.6 mm per day. Now we will give other details. Here we will enter the relative humidity as 55, sea level pressure as 29.93, and the station pressure as 28.57, Harley visibility as 28.57, and the wet bulb temperature is 10, wind speed is 42, and Ozark aquifer depth of water is 220.03, and the weekday as 2, and the day and night as 1. Now we will click on predict. So it is predicted that heavy rain when the precipitation rate is greater than 7.6 mm per hour. In this way, by giving the rain related details, which is humidity, pressure, temperature, we will be getting the predictions which are heavy rain, moderate rain or normal rain. Now we will sign out. The project significantly enhances data imputation accuracy, especially for large data gaps, surpassing existing methods. The innovative reshaping of sensor data successfully leverages correlations between missing and observed values, boosting imputation accuracy. Various machine learning algorithms contribute to the project's success, addressing different aspects of the data imputation challenge. The project strategies are relevant across domains, reliant on sensor data, ensuring better decision making and insights by improving the data quality.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.